My name is Joshua Kinney. I am the Game Development Curriculum Manager here at Pluralsight. You can see my Twitter handle there, and then my portfolio if you want to take a look at that. So today we're just going to talk about lighting and rendering in Unity. And I want to get a little bit deeper than just working with the lights themselves and the core features. I want to really specifically look at ways that we can troubleshoot and optimize our scenes. And so we're going to look at a lot of the common pitfalls that happen and a lot of the common questions that come up whenever we're talking about lighting and rendering in Unity. So just to kind of give you a little bit of a summary on what we're going to be covering specifically, we're going to take a look at the rendering paths. A big question that comes up is, should I use forward rendering or should I use deferred rendering? Which one is better? And we'll kind of talk about how to determine that and what's going to be best for your project. The second thing that we'll talk about is light optimization and troubleshooting. So we're going to look at all of the different light types, and we're going to really dig down deep into what those light types are and how they interact with objects in the scene. And then we'll go into improving and optimizing shadows, because a big thing that comes up is things like my shadows have a lot of artifacts. They just don't look good, and things like that. So then we'll kind of tie off the end of this by talking about global illumination and real-time and baked global illumination and what that means. And we'll talk about some of the pitfalls that come along with that. And then we'll also just kind of dig in a little bit. I don't want to go too deep to where we're getting down into the mathematics of things, because I get lost whenever I'm doing that. I'm an artist. I'm not a programmer or a developer or anything like that. But hopefully we can just kind of look at those different aspects. So how is this really going to help you? So knowing how lights and shadows work under the hood, so to speak, will help you make better decisions when it comes to balancing graphics with performance. That's the main goal behind this. So with that, what we'll do is we'll go ahead and we'll get started. I'm going to go ahead and share my screen here so everybody can see that. And we're going to start in by answering our first question as to which one should we use, deferred or forward rendering. So looking at the scene here, you can see that it's lit pretty well. This is not lit in a way that we would actually play a game, because there are lots of different lights in here to just give it that artistic feel. So looking at this, where do we determine using forward rendering or deferred rendering? So let's go ahead and go to Edit, and then we're going to go to Project Settings and Player. And right here in the render settings, you'll see forward and gamma. So let's go to the rendering path of forward and switch it over to deferred, and you're going to notice a little bit of a difference. You'll notice that with deferred lighting we lose fog that was in the scene. However, there's not a humongous difference as far as the look of it other than that. There are options that we could use to get that fog back by actually using a fog object, but in this case I'm going to go back to to forward. A big question that you could really ask yourself in this is, if you're really not sure of which one to use, the forward rendering is going to be your safest bet, because it does have the most options just right out of the box. So for example, if you are going to be using, let's say, transparencies or translucent materials, or you need something to support anti-aliasing, forward rendering is going to be the best thing for you. Now deferred rendering is best if we have a lot of real-time lights in the scene. So if we just have an enormous amount, let's say that we have a day-night cycle and we have lights that we want the player to be able to turn on and off, maybe the deferred rendering method would be best for us. So those are just a couple of things to think about, and those are just kind of general guidelines. So with forward rendering, let's go ahead and just kind of talk about that a little bit more, get a little bit more in depth with that. So forward rendering has a very low upfront performance cost. The cost will scale up, though, with the complexity of our scene. So when we talk about complexity, that means most of all that how many lights we have in the scene, what kind of lights those are. Are they real-time lights or are they baked lights? Those are all going to be things that we'll just need to ask ourselves. Now, the biggest equation that's going to come into this is the fewer pixel lights that we have in our scene, the faster the performance is going to be. Now, we're going to talk a little bit more about pixel lights here in just a moment. Also, forward rendering is easier on the GPU with fewer draw calls. It runs really well on mobile VR devices. And like I said before, it supports anti-aliasing and translucent materials. So if you're planning on porting your Unity games over to a mobile platform, forward rendering is going to be the best thing for you. So let's go ahead and talk about the pixel lights and vertex lights and just kind of talk about the lighting optimizations and troubleshooting in that. So I'm going to bring up a different scene here, and I want to just kind of talk about pixel lights and vertex lights. And we'll get into how Unity actually renders these lights and what is the significance of a pixel light versus a vertex light. So pixel lighting is calculated separately at every screen pixel. So it's done on an object-by-object basis. So to put that plainly, let's go ahead and go to our scene view here. You'll see I have this crystal that's illuminating with a light. And that light itself is emitting out to the range of that light. Let me actually select the light itself. Let's do it this way. And we have our range and then we have our intensity. And you can see that that light is spilling onto the spaceship. It's also spilling out onto the ground. And it's accurate. Okay? Now vertex lights calculate the illumination only at the vertex level of a mesh, and it interpolates the vertex values over the rest of the surface. Now, that's a lot of technical speech there, but let me go ahead and just show you what I mean by that. So pixel lights, we can see them just kind of like this. Let me bring in a spotlight, and let's just make this very evident. So with this spotlight, you can see it's underneath the ship here. Let me pull this out. And you can see that it gives us this really nice circular shape. Okay? It's very accurate. We can cast shadows with it. But if it was a vertex light, it wouldn't be quite as accurate. So let's go ahead and just kind of display what a vertex light would look like. So we can do that by switching the render mode of this light from auto to not important. And you'll see how that changes drastically. So what it's actually doing, if we select the mesh of our terrain, well, it's not going to show me that. Let's go ahead and put this light on our ship. So looking at the ship, this is a very low polygon ship. And you can see that the light is spreading. Let me also turn off the direct light. That's going to make things a lot easier. So with this, if I switch this back to auto, you can see that we get the actual shape of that spotlight showing up there. But by switching it to not important, that determines that it's a vertex light. And so what it's doing is it's calculating the light that is on this vertex here, and we have another vertex right here on the mesh. And so what it does is it interpolates the values from this vertex to this one and gives us this linear look. Now, whenever we're using scenes like this, it can be a little difficult to see. So what I'm going to do is I'm actually going to break it down to the basics instead of using this scene. We'll come back to this here in just a moment. But let's go ahead and go back to something like a Cornell box. And let me find my object here. Yeah, there we go. For some reason, it didn't want to zoom in on that. All right, so direct lights are always going to be pixel lights. Okay, let me go ahead and turn that off, and let's bring in that spotlight again. So again, we get the exact shape of that light. And let me bring this over my sphere. You can see it's rendering every single pixel on the screen. But if I set that to not important, watch what happens. see how it spreads out? It's interpolating that light and spreading it over the object itself. Now, it's not bad. It's great for further distances. We really can't tell that much. But where it comes in handy, are further distances like that. But whenever we start getting up close, we want something that looks like this, something that looks a little more accurate. So the way that this renders out, just to kind of step back for just a moment, the way that it renders out is lights whose rendering mode is set to not important are always rendered out as vertex lights. And then the brightest directional light in the scene, like this one, is always going to be a pixel light. Notice the accuracy that it gives us on our shadows and on our objects. The next thing is if lights are set to important, meaning they are forced to being a pixel light, they will render out as a pixel light. And then if the above results, so if all of those things are met and the pixel light count in the quality settings is still not met, then it will go ahead and render out all the lights as pixel lights. So I mentioned the quality settings there. Let's take a look at that really quickly. So if I were to take this particular scene and I went to Edit, Project Settings, and Quality, you can see right here that I have pixel light count set to 4. Let me go ahead and go to the fastest quality settings. Notice that I've lost all of my shadows. Those are not being supported. My directional light is still creating that pixel light there. Let me go ahead and turn that off. But again, now everything is set to vertex lit, like this spotlight here. Now even with those settings on the quality, let me go ahead and switch this to important. And you'll see how it forces that. But let me switch it to auto, and it goes back to that vertex light. Whenever the render mode is set to auto on your lights, it's automatically going to revert to the quality settings. So hopefully that makes sense. Well, let's go back to those quality settings. And let's bump this up to fastest. And you'll see that my pixel light count is still set to 0, so there will be 0 pixel lights in the scene unless they are forced or it's a directional light. And then once I go to simple, you'll see pixel light count is now set to 1, and then we have one single light in the scene, and it's now able to render that as a pixel light. So if you notice some shading that looks wrong, this is probably the first place that you'll want to look. Now whenever we have our quality settings like this, let's say it's set to 1, and I go ahead and I create another light in my scene. Let's create a point light. You'll see how it's popping back and forth. So what that is doing is it's recognizing that, okay, well, we only have 1 pixel light count. That's the max that we can use in our scene. Both of these are now set to auto, okay, in the render mode, so nothing is being forced. And now Unity is automatically determining which one gets to be most important. So what that is based on is the brightness of the light itself with the range. So how close is it to the object? So you can see that we're getting most of our color on the point light now, and then now it's back to that spotlight. So if those things come up in your own projects, just be mindful, and that's the first thing that you'll want to check. So now that we've kind of talked about the rendering flow of each one, let's talk about improving our shadows. So let's add some shadows into our scene. So what I want to do is I want to go back to my scene that I had before. And let's go to the pixel lights. And let me find my object. Okay. And so as I zoom in here, you can see that we have some shadows, but there's a lot of artifacting with these. And we want to be able to bump that up. Now this is also being controlled by the quality settings. Because we changed them in the last scene, it's going to update every other scene here. So let's go to the project, settings, and go to quality, and we're using simple. So again, you can kind of step through that and you can see the changes that are being made through the quality settings. And then as I go to good, you'll see that we get soft shadows now. Things aren't artifacting quite as much, and we get more and more resolution the further we go. So whenever we cast shadows in our scene, that's going to, obviously, that's going to bring up, well, it's going to lower the performance. We're not going to get quite as many frames per second. But there are lots of things that we can do to curb this and to just kind of balance the shadows. So if you're developing, let's say like this, think about you're developing for a PC, a high-end PC. But what if we're developing for mobile? We're not going to be able to get these fantastic shadows. We need to bring those down a little bit. And we have to start working, I don't want to say smarter, but we have to do a little bit more trickery. We'll start using things like cookies and things like that. So with shadows, we want to use real-time shadows sparingly. So whenever we select a light, let's select this point light here, we have our shadows types to soft shadows. The lighting is set to real-time. But let me go to my lighting here. And let's see, where did my shadows go? And of course, I'm drawing a blank here. We'll go ahead and we'll come back to that here in just a second. Let's go to the cascading, because this is one of the major tools that you're going to need whenever dealing with the quality of your shadows. So let's go to the Edit and Quality settings. And here we go. We have our hard and soft shadows. We have our high resolution for our shadow resolution. You can bump that up and down. And this is kind of the global version of this. So if you're going to mobile for this game, you can set your shadow resolution down to low. Okay? But what this is going to do is it's going to update these values here. So let's talk about the shadow cascades, because these are going to be really great to help us with our directional lights. If I were to set this down to no cascades, you'll see that our shadows get noticeably lower resolution. Now a cascade, let's switch this up to 2. What it's going to allow us to do is whenever we move closer or further away from a shadow, it's going to drop the resolution of that shadow. Now I can visualize this by going up to the scene and then going to global illumination. And it looks like, I wonder if that's going to show up in the webinar because it's flickering. So I'm looking for, where'd you go? Shadow cascades, there we go. So you can see that we have this color swatch that comes up. And it is directly proportionate to the colors that we have here in our shadow cascades. So back beyond this point here, our shadows are going to drop down to their lowest level. So let's go ahead and just draw this down. And let's make this smaller. And let's hit the shadow of that ship. And just watch that dissipate. Let me bring this down. And I'm going to turn this back to shaded. And you'll be able to notice the difference. Now, even though that is at a lower resolution, it's still not a bad shadow, especially if we're thinking about this being a mobile game. Now, the higher amount of cascades that you have, the smoother that transition is going to be. So as you can see here, we have this very rough transition. So if we were playing in a game and we saw that, that would definitely pop in and out. So to have something of a little bit higher quality, you might think about using 4 cascades. But like I said, if this is going to be for a mobile game, 2 cascades or none would probably be best. So the cascade splits, this is going to be directly dependent on the shadow distance here. So if I come in and I say, let's cut it in half, let's do 75, you'll notice that the shadows changed drastically. Let's switch this back to the shadow cascades. And as I start to draw this up, let's take it back to 150. You can see how that changes. So just be mindful of that, because that's one parameter that you might miss whenever working with these cascade splits. Okay, so now that we've kind of talked about those and our shadows, I want to discuss one of the parameters that gets asked about quite a bit, and that's going to be our shadow biases. So let's go to back to shaded view. And let's select the point light here. And actually, I need to select my object. That's where my shadows are. So under this particular object, you can see that it's receiving shadows. What? Now I'm losing it. Of course, it'll be a live demo whenever I lose it. Let's see. There we go. Okay, so under the light itself. So whenever we're talking about shadow biases, there are going to be some situations where lights just don't look right. And I use that subjectively. There's really not a wrong way of doing it, but sometimes lights, they just don't really look correct, but they're there. So let's go ahead and adjust like the normal bias here. Whenever we adjust this, what it's going to do, well, it's not going to bring up my, see, I'm using a light. Should be adjusting these shadows here. I'm not sure why it's not. Oh, there we go. So whenever we adjust the bias itself, you'll see it kind of raises out from underneath the object, and this is detaching the shadows. And you can see this on the other objects as well. Sometimes we can tweak these values just a little bit to sharpen up the edges, to make them a little bit nicer. The normal bias is going to, it should adjust the overall width of the shadow, but for some reason it's not taking effect in this one. So it wouldn't be a live webinar without something working as it should. So let's go ahead and bring in the Cornell box again. Maybe that'll help, because I know for certain that I had it working in here. So let me take my directional light. Oh, I completely forgot. That bias will work with the directional light. So let's take this and let's adjust that normal bias. And as you can see, it starts to kind of fade the shadow edges a little bit the higher that I go. So it kind of shrinks that away. And then if I adjust the bias, you can see that it starts to detach from the objects themselves. So if you have a lot of artifacting on your lights, you can take care of that. Now, one thing that you'll notice whenever I knock this down to 0, we have objects that are trying to self-shadow themselves. So we get what's called shadow acne on our objects. So if you ever have that at a lower quality setting, you can adjust this normal bias to kind of clean that up a little bit. Okay. Now you can definitely see it on the sphere itself here as well. So anytime that you get self-shadowing, that's going to be the thing that will fix it. Just be careful of the shadow detaching itself from the object. All right, so now we've kind of talked about some of the major things that comes up with shadows. Let's talk about global illumination a little bit. Global illumination is probably the greatest feature that lighting has inside of Unity. But there's a lot of things that go along with it. So just to kind of get started with this particular scene, I'm going to come in and I'm going to select my objects, and I'm going to set them to static, because they have to be static in order to bake out the indirect illumination and things like that for our lighting. So I'm going to switch these over to static. And you'll notice right here at the bottom that I'm getting this bar, and it's starting to bake out these lights. And the reason that it's doing that is because in my lighting options, it's set to auto. Now, anytime that you bake out lights, and this is set to auto, and you make a change, it will update that. But whenever we do bake out lights, it creates a GI cache, And so any other changes that I make after this will start to go a little bit faster. So usually that first bake is always the longest. Now this is a very simple scene, so that went pretty quickly. Larger scenes and more complex scenes, especially when they have anti-aliasing and they have different effects like depth of field, well, not really depth of field, real-time shadows, we have a day-night cycle or something like that, those will go up quite a bit. Now the big thing that we get tripped up on are these two options here, is Precomputed RealTime GI and Baked GI. Let's go ahead and take Precomputed GI out of the equation. You'll notice that it's going to go ahead and recalculate this, and you really won't notice that much of a difference between the bake that we had before and this one. So I'm going to give that just a moment to finish baking out. And I promised it wouldn't take that long. Okay, there we go. So now you'll see that this is actually quite a bit different. The reason for that, let's take our ambient occlusion. We'll leave that at 0. So we've got some problems with this. We're not getting light to bounce all the way through. So let me check my ambient intensity. Ambient GI is not working. Okay, so I'm going to make some adjustments to the ambient intensity and just kind of pump that up a little bit higher. And actually, I might have my light set to real time. Okay, set that to baked. That should give me the look that I'm looking for. So just to kind of, while we're waiting for this, Baked GI is going to bake all of your maps into a light map. And what it does is it reduces the amount of computing that has to happen at runtime. And so it's going to make our scenes run very smooth, and we're going to get really nice looking scenes like this. So you can see that we're getting some bounced lighting off of the red wall onto this ball here. Same thing for the green wall here. You can see it bouncing here. Okay, and we're seeing that spill out over the other objects. Now, baked lighting is going to give us a really, really nice result. Now, Precomputed RealTime GI can be a little confusing at first, but once you kind of understand what it's actually doing, it tends to make a little bit more sense, and you'll learn how to control it as we go along. So Precomputed Real GI, what it does is it precomputes real-time light sources in our scene. And it does this by precomputing every possible way a light can bounce through the scene. And so whenever we have scenes like day-night cycles, this is going to be really handy because what that will allow us to do is have those, and we know that we can have objects in the scene. They're going to have indirect light pouring on them, even though we have a light that is moving, or a real-time light. So with this directional light, just to give you a quick example of that, if I were to spin this around into a different direction, it's going to go in and it's going to bake again. Okay, so it's going to override that light map that was there before. So if I were to switch this light over to real time and then activate the Precomputed GI, it's going to bake that out or pre-compute that, and then we could do something like a day-night cycle. Let me go ahead and bring in a script and put it on my direct light here so we can actually see that. So I have this script called auto intensity, and you can actually get this from Unity's website. They have a day-night cycle blog post, and this is the script that they used and put that on the directional light. So let's go ahead and add the component, and let's go to scripts. And I'm going to go to auto intensity. And you can see that I can start adjusting things like my day-night color. I already have some presets here. So this gradient is basically what it's going to do is it's going to change this color based on the rotation of the sun or what time of day it actually is. And I have the night-day fog color, which I'm going to use here. And then there are going to be some values that I'll change here. Let me set my max intensity to 0. And let me set this to like 1.2. Whoops. And 1.4. Now to get this to actually rotate at runtime, I'm going to set this to like -20 on both the day rotation speed and the night rotation speed. So with this, you can control how fast the day-night cycle goes during the day, and then you could also speed that up at night. Normally that's how games will go, but you can make it be consistent like this. So let's go ahead and see this in action. If I go ahead and switch this over to real time, and let me switch this back, and we're going to get that rough looking light map again, but give me just a moment. I didn't think it was going to take this long to bake these, but that's part of it. Now there are going to be some ways that you can reduce the baking time. It could be things like the UVs on the objects, and those are all found in the object tab here. So whenever we select an object, we can preserve the UVs, so the ones that are already on the object, or we can check that, turn it off, and have Unity recompute that and set up UVs for us automatically. I would suggest using the preserve UVs, but that's neither here nor there. So let's go ahead and hit play. And oops, let me bring my camera back over here. Let me select my camera and hit Shift Control F, and then let's hit play. So you'll see that the global illumination, whoops, looks like it paused that. Let me go ahead and try this again. I didn't realize it wasn't done. Okay, there we go. All right, so you can see that the baked global illumination is staying in place even though my light is currently going through it, a day-night cycle. Now I do get some ambient light on this, but that's not what I'm really worried about. I don't want it to look like it's in the day all the time. So what I can do is I can change my lighting settings here. So let me go to, and I'm missing it. Let me go to my light, and let's go to Precompute RealTime GI. I'm going to set my resolution to 2. We might go a little higher if we need to. And then I'm going to tell the scene that it has unlimited access to my CPU at runtime. Okay? So whenever we have that set up, I'm going to turn off the baked GI for now because I'm going to talk about a combined workflow here in just a minute. So now that we have this, I can go to my light maps, and you'll notice that it's not doing anything. It's not updating or anything like that. So let's go ahead and turn this off. Let's build. And it's going to go through, and you'll notice that a couple of things were created. Let me go to my global, actually, where did my, there it is, under Cornell box. It created a new folder, and it created this lighting data, and then my reflection probe. Okay. Now that lighting data, we can come back to that here in just a moment because it's going to help us with multi-scene editing. So let's go ahead and hit play. And you'll see now that we're getting the lighting in there. And we should see our indirect illumination, but that's not showing up. Let's see. I know I've missed one thing. Let's see, real time. And see, auto, that's good. Scene. Let's see. Let me go to my quality settings, make sure that I'm able to do this. Yep. Okay, so that should be good. Go to my player settings. We'll go to linear. on this. I'm going to get a better result on that using the linear color space because I'm using standard, the standard shader here. Go to Deferred. And let's play this. I'm missing one thing, and I know. Let's see. Mesh render, cast shadows is on. Oh, okay. Wait a minute. Let's go to, I tell you what, let me bring up a scene that I have this set up. I wanted to make it really easy with this, but for some reason well, I'll tell you what. Let's go ahead and let's combine the Precomputed GI with the baked GI. So with this, let's go ahead and select my Directional Light, and go to Lighting here. And let's turn on baked GI, and I'm going to set this to auto. You'll see things start to rebake here. And right now we're not going to get any direct illumination. So let me go ahead and pause as soon as I get up there. Okay. So now we've got it. You can see that the illumination is coming into the scene, so we're getting that red spilling over and we're getting the green. I wonder if I had that before and I just didn't see it, because I tend to do that. And of course it goes dark, so I've got to wait for it to come all the way around again. Okay, it was there, I just didn't see it before. Okay, so it wouldn't be a live webinar, like I said, without little hiccups like this. All right, so we do see that we have our indirect illumination. Now this is Precomputed GI. And so what it's doing is it is pre-calculating every possible scenario for the light. And so we can have day-night cycles with this indirect illumination on top of that at real time. Now, there are a couple of things that that I'm concerned about with this, because whenever I play this and it goes dark, oh, there we go. Now I've lost it. So now everything is dark. And let's bring that back again. And you'll see that we're now getting that indirect. So Precomputed GI. Now let's go ahead and add some reflections into this, because I'm using just a standard shader that's basic roughness. And we have to think about our reflection probes and things like that, even when we're using this Precomputed GI. So let's turn that off. And let's bring in a reflection probe. So I'm going to go to Light, Reflection Probe. Okay. So I have my reflection probe in the scene. You can see that my object is reflecting. I'm going to change my sphere. I want to change the material of that sphere. And let me create a new one. Let me just duplicate this. And I'm going to set this to white. And then I'm going to take my smoothness up. And you know what, let's even take our metallic value up. Let's make this a chrome ball. All right, so here we have our ball, and you'll see that we have this black spot in the scene. What it's doing is, because of the reflection probe, it's reflecting itself. So whenever we move this reflection probe around, you'll see that it updates the actual object. Okay, so it's based on the position of that. So what I want to do is I want to remove this guy from the reflection probe. So the way that I can do that is by creating a layer, and I'm going to add a layer. And let me call this Reflection Probe. Okay. And then I'm going to select my object. Or actually, yeah, I'm going to select my object, and I'm going to put this on the reflection probe layer. And then I'm going to cull anything on that reflection probe layer. So now that's being removed. Now the shadow is still going to be there. It's not that big of a deal. I'm not too worried about that. We can adjust this. We can pull the reflection probe above the object, so it'll make that shadow look a little bit more natural. Okay. So now that we have this in there, how does the Precompute GI going to work with this? So let's go ahead and play, and you'll see that we're reflecting that, and everything is being reflected inside of the Cornell box as well. So how do I get that to work with real time? The first thing that we're going to do is we're going to change the reflection probe type from baked to real time. So now let's play it again, and we're still getting the same thing. So what's happening here? Well, it's not updating. Even though it is real time, it's only taking the very first frame. So the refresh mode is on awake. So if I set this to every single frame to where the reflection probe is going to update that every frame, this should work properly. So now you can see that my Chrome object is now reflecting that. And then when the day-night cycle comes in, we're getting our reflections with our indirect illumination. And so now we've just created real-time indirect illumination or global illumination along with that. So a couple of caveats that come along with that. It's very expensive. So if you are creating a game for, let's say, PC or something like that, this would be great, especially if you had incredible hardware. But if it's going to be for mobile, this probably won't work, especially because this is in linear color space. It won't work on mobile. So just a quick tip, if you're working on mobile, you have to stay in gamma. All right, so now that we've talked about that, I know I'm running out of time here, and I feel like I've rambled on, and I apologize for that. So hopefully you've gotten something that resonates with you and something that you can start tweaking with. Really quickly, whenever we are baking out our global illumination, what it does is it stores that into a GI cache. I mentioned that earlier, and I want to be able to show you where you can access that. If you go to Edit and Preferences, it's going to bring up your Unity preferences, and you'll see GI cache here. Right now, you can see where it's currently storing that data and how much it's storing. So you can see it's 6 gigs. So if you need to clear that, you can just simply hit Clean Cache, and it will remove that. And then the next time that you bake that out, it will go ahead and put that back in that location. If you want to put it in a different location, you can always choose the cache file location and do it that way. And then you can also limit the maximum cache size in gigabytes. So 10 is usually pretty good, but whenever we start getting very, very large scenes, it might be helpful to bump that up a little bit higher. But just in case you were wondering where that's at, that's how you can manage that. All right, so I want to give some time just for some questions so that way I can kind of answer those. I feel like I kind of wandered around a little bit, so hopefully I can start answering any questions that you might have and give a little bit of intimate time with that. So let me go ahead and stop sharing the screen for now, and then we'll come on back to that. Okay, so I have some questions here. Okay, so the first one, can you change / choose the amount of interpolation you need with Vertex lights? That's a great question. Let me go ahead and bring that scene up again. With Vertex lights, no, you cannot, because what is actually happening with that? Let me bring my scene up here. And let's take this material, and let me switch it back to white. No smoothness. And I'm going to remove my reflection probe. this off. And let me turn off my directional light because that's always going to be per pixel. And let's bring in my spotlight. Okay. So just to look at this really quickly, if I were to set this to not important, so it forces it to be a vertex light. And for some reason, that is not changing at all. See, we have real time. Let me go to my quality settings and actually force that in the project settings because it might be overriding it. So let's go to simple. Not changing it. Did I bake a light map out and didn't realize that? Okay. Well, let's see. I have this. And that is still set to static. Let me bring up that original, a different scene, because I'm going to waste too much time. Let's see. Let's go to this one. Okay. So this should be working properly. All right, so with this light, let me change it to not important. And it doesn't appear to be. Let me make sure I'm in forward and gamma. I bet that's what it was before. Yep, it was. Okay. All right, so with this light, let me do a spotlight so we can actually see its shape. And let me bring in a sphere, because it's really easy to see on the sphere. And let's see. Okay. Let me take this guy. Let me turn it off. And I'm going to turn off the directional light. Okay. So right now it's set to not important. So we have the vertex light here. What's going to happen is to answer your question, what it does is it samples the light value or the color value and the intensity per vertex. And whatever hits that vertex, it's going to interpolate that to the next one. So they basically get assigned values. So from this vertex to this one, they get a color and the intensity. And then those values are basically interpreted from here to here. Now you can adjust by increasing the resolution of the actual model itself, and that would kind of help with interpolation, but that's probably not something that's going to help performance at all. Okay, so hopefully that answers your question. Let me go back here. And let's see. Let me start at the top here. I think is it going top to bottom? Can't remember. Oh, I answered it. Okay. So does normal bias heavily affect performance? No, it's not. It doesn't heavily affect it. You are going to get a little bit of a hit on that, but again, no, it's not a major killer. What light settings do you suggest for a mixed reality setup such as HoloLens? That's a really good question. I haven't had the pleasure of working with the HoloLens yet or augmented reality, but based on what I've seen from like VR, we want to think in ways of kind of like mobile. It's going to be very intensive. basically, like with HoloLens, you have a computer strapped to your head. So you're not going to get the best you're not going to get like the best video card or graphics GPU or anything like that. So let me just make sure that I answered that. I would start out with what I would think for mobile settings, and then move up from there. Do combining the two lighting systems, real-time and pre-comp, affect performance? Yes. So if we were to use baked GI and precomputed GI, we basically get taxed for both of those. Now, baked GI is a very small performance tax, but it is added on top of that. So yes, it does affect performance. How did you fix the indirect illumination? So I think that was talking about the Cornell box. Let me bring up that scene again. And let me go to, oh, that was the wrong one. My sphere. So the way that I fixed it on the indirect illumination, you're talking about the precomputed GI on that. The way that I fixed that, let me turn that off, was, actually I remember now. It was there, I just thought that it wasn't. The main thing to remember is that the objects that you want to be affected by that indirect illumination, the objects need to be set to static in the inspector. Or at the very least, they need to be set to light map static. Okay. So here you can see the direct illumination popping in and out on that. Do combining the two lighting systems, real-time and pre-comp, affect the performance? Yes, I did. How did you fix the indirect illumination? I just didn't notice it. Suggested starting points, lighting and rendering pipeline, quality settings for VR applications, starting high-end non-mobile workstations. Suggesting starting points. So with VR, the first place that you want to start is those the player settings. With VR, I would stick with forward. And then color space, I would go with linear because linear just looks better. One note on color space, you can use gamma or you can use linear. I like linear better. Like you can see here, it just looks way better. But if you start in linear, stay in linear. If you start in gamma, stay in gamma. Now, it's not impossible to move from one to the other. You're just going to have to do some reauthoring of your light intensity values, maybe even some colors, and you'll also have to reauthor your materials. So switching back and forth, it does take a toll, and there will be some problems that go with that. So hopefully that answered that question. So forward and rendering. Whenever you're working with VR, like light baking and things like that, you can use the real-time GI, just like I did here, along with the baked GI. I think that would give you a good result. Whenever I think of like a VR experience at a very high level, I think of like ArchViz. So whenever you see a walkthrough of an apartment or something like that, they're using precomputed GI for daylight cycles. If that's there. If it's not there, I would just get rid of precomputed GI altogether and only work with the baked GI. What's the preferred way to develop augmented reality apps for iPhone? Like I said, I haven't really gotten into augmented reality apps for iPhone. I don't know if that answers your question. Like, are you talking about for lighting and things like that? For augmented reality, I think a safe place to start, is kind of like normally developing for any mobile device. I would love to look more into into augmented reality. Hopefully, that's a tutorial that we can work on really soon. But Yeah, sorry, I can't answer that any better. I really haven't had the chance to work on that. Do you use Shader Forge? Yes, yes I do. Shader Forge is awesome. If you buy one tool on the Unity Asset Store, Shader Forge should be that one. And it says, I know this is a bit off topic, but what can you tell me about Unity and WebGL as far as lighting goes? Not much, unfortunately. Whenever I create tutorials, I typically only get to stay in like standalone. But like with WebGL, as you can see here, I don't have the module even loaded into Unity. So I'm not exactly sure of what the capabilities are. I'm pretty sure you won't be able to get all of the lighting features that go in that. But normally whenever you switch over to like, let's say that you switched over to a WebGL project, it will give you some warnings on like what you can use and what you can't. So just to give you a quick idea of what that looks like, whenever I have, let's say, a point light in my scene, notice this little warning here. It says currently real-time indirect bounce light shadowing for spot and point lights is not supported. It's giving me that warning because bounce lighting intensity is set to 1. So whenever I turn that off, it goes away. Unity's pretty intuitive that way. So hopefully that answers your question. Again, it's another one where it's like, I don't really know. Can you recommend any toots or references for the Unity and WebGL? No. If you want to know about like getting started with lighting and rendering at all, there is a tutorial on Pluralsight called Lighting and Rendering in Unity. That's a great place to start to learn all about the different light types and all of the core features. I will definitely put that on a list to talk about, maybe in the future as far as WebGL goes and lighting. I would definitely like to look into that. But no, unfortunately I don't have any recommendations or references for that. Any other questions?
Hey Josh, would you,
yeah.
I don't have any other questions coming in, but would you show us that warning on your, would you share your screen and show us that warning that you were talking about when you answered that last question?
I completely
it just
forgot.
stopped sharing your screen the last 2 questions, and I think that would be helpful.
Yeah, thanks. See, without Lindsay, I'd lose it. Let's see. So the warning that I was talking about, hopefully you can see that now. So Unity brings warnings up like this all the time. So currently real-time indirect light bounce is not supported on point lights or spotlights. That's because I have a point light in my scene and my bounce intensity is set to 1. So if I set that to 0, it goes away. And there are other warnings and things like that. So you can see one right here with lighting. It says for the directional mode, it says directional light maps cannot be decoded on SM2.0 hardware, nor on GLES 2.0. So it'll fall back to non-directional light maps. Now this is not saying that I don't have the hardware to run this. It's just a generic warning, and it will always be there whenever we use this directional mode. So if WebGL falls into this exception, then something like this won't work. So hopefully that answers your question. Okay. Do you have any shaders to show on that other scene? Which scene?
It doesn't look like we have any clarification on that last question, but it also looks like we're out of time, unfortunately.
Yeah.
Unless you want to hang out a little bit longer. It looks, he's saying the very first scene.
Okay, the very first one.
With the spaceship.
Okay. Let me bring that up.
we're just about out of time, so you have a couple of seconds to talk about that if people want to stick around.
Yeah, so with this, let me switch this back to gamma. You can see there are a
good... And we don't have your screen up just yet.
Oh.
Sorry.
Okay. Thank you. So I was getting ready to say that whenever I first brought this up, this scene was in linear space, and so you can see how just awful that looks. That's because this scene was built in gamma. And so by switching it to linear, you're going to have problems like this. Now you could get it to linear, but you would have to reauthor lights and materials and things like that. So the question was, I can't see the question now that I'm sharing the screen. Let me see if I can remember that.
I'll read it to you. It says, did you have any shaders to show on that scene?
Okay. Yeah, so with this particular scene, we're using a terrain. So the terrain is made up of splat maps, and so that's what we're getting on the ground. Each one of these textures, if we were to double click on this, let me bring it over here, you can see that it has an albedo and then a normal. So that's being applied there. Also, while I'm thinking about it, normal maps, they will not show up if you have, if your light is set to not important or it's a vertex light. That's another downfall of using vertex lights. Also, let's see, the grass, just to kind of talk about that. You can see the grass textures, they're just alphas or grayscale images, and then we're using the healthy and dry color to tint those. And then for the trees, let me select one of those. So with the tree, this has, well, let me go to the project settings. I think this is under Dreamscapes. Now, Dreamscapes is, you can buy this on the Unity Asset Store. It's really, really great to kind of start messing around with, and I think it's ready for mobile. So let's look at the trees and the materials on that. So you can see this is kind of like bark. This is using the nature shader for the tree creator, and that's what all of these are. And then here we have for the leaves themselves. So that's using alphas, kind of like an alpha cutout. And then they're just being tinted by this main color here. Okay, this one's really not that complex. It's fairly inexpensive. Just to kind of pull back a little bit, you can see the scene. It's very small, and it's only meant to kind of show that one area. You can see the background here is an actual object, and then the skybox material. Let me bring that up too. So like backgrounds and skyboxes, you can see that's the skybox that we're using for this. So pretty basic shaders. Any other questions?
Cool. Well, I think we are just flat out of time for questions, unfortunately. But very cool presentation. Did you have any closing thoughts or final comments you wanted to make about the topic that you covered today? So
with lighting and rendering, it's going to be per project basis. So there's not a real formula that you use for this. I mean, you're going to get your levels and you're going to start building them out. You may have specific needs. So if you have, let's say, normal maps, you want to be able to use those, and you want really high look, so you want global illumination. You're going to think about using maybe the deferred rendering mode if you have a lot of real-time lights. If you know all the little caveats for that, and you know what your project is going to look like, then you can start making better decisions. And so hopefully that's what this will help you to do. If you're working on mobile, stick with that forward in gamma. You could use linear, or no, actually you can't use linear with mobile. So forward and gamma, those are going to be some restrictions. You'll want to use lights that are really cheap. You'll want to get creative with how you can start creating shadows by using cookies. And then you'll have to rely on some of those vertex lights a little bit more rather than pixel lights. So important and not important. And also, whenever you're rendering your scenes, there's really not a correct or wrong way. Whatever you need in that specific scene, if you need to, let's say, reduce the draw calls and things like that, use the profiler and the frame debugger. You can find those in the window here. So those will be great places to start to help you start digging in even further into how you can affect the performance. Remember that performance is key with all of your games. Even if it looks great, but if it doesn't run right, if it's slow and buggy, people just simply aren't going to play the game. So always go for performance. So I hope you guys learned a little bit. I know I rambled on and on. I guess that's what you get with a live webinar. And thanks for listening in and hanging out with me.
Well, thank you so much, Josh, for presenting for everybody, and thank you everyone for sticking around and your awesome questions and participating today. Again, please feel free to continue the conversation. Follow us on Twitter, tweet at us, let us know if you had additional questions that didn't get answered. Again, we're going to pick one winner at random and give away a free month of training, so you can log on and take Josh's course and follow the whole thing from start to finish. Just tweet about your experience today with hashtag PluralsightLive. You can also email us directly if you have questions at webinars@pluralsight.com. We did record the presentation today. We'll get that up on our resource center on our website as soon as possible. We'll let everyone know as soon as that's ready. So thank you once again, and thank you, Josh.